we're going to start looking at graphs of motion. So this is a position time graph to start with, and there's a lot of information here that we can learn to interpret by looking at the graph. The first thing we want to do is just kind of orient ourselves with the graph as a whole. So here along the y-axis is our position. So we go positively from 0 to 10 meters and negatively from 0 to negative 5 meters on this graph. And also this is on the x-axis, this is our time in seconds. So we go from 0 to 10 seconds in this graph. What this graph isn't is a depiction of the motion of an object in space. So it's not that an object starts here and then goes to the right and then goes down and then goes back up again. That's not what it is. We're really just looking at a horizontal motion. So on this graph, at time equals 0, or at our initial starting time, our object is at 3 meters. So it's just standing at 3 meters when our time starts. 2 seconds later, this object is still at 3 meters. So this object just sits at 3 meters for 2 seconds. Then, between times 2 and times 4, our object moves from 3 meters all the way down to negative 5 meters. So that means that our object moved backwards. Remember, we said that positive was forward and negative was backward. So our object moved backwards to negative 5 meters between 2 and 4 seconds. Then our object moved from negative 5 meters back up to 3 meters between 4 and 10 seconds. So our object moved forward. And that's what we can tell just by looking at the graph what our object did. Now we can also tell some other things from this graph. So we can calculate displacement. So let's start there. So we know that, let me write this in words, I suppose. So displacement is the final distance minus the initial distance. That's it. So when we look at this graph, we can say that our displacement is our final distance, which is at this point here, which is 3 meters, minus our initial distance, which is that point there, which is 3 meters. So our displacement is 3 meters minus 3 meters, or 0 meters. That's our displacement. What about distance? We can also calculate distance from this graph. So distance, remember, is the total distance, the sum of all path lengths of the object. So what this object did is it went from 3 meters and it traveled backward to 5 meters. So that's a total of 8 meters that it traveled. And remember, distance is always positive, so it doesn't matter that it's forward or backwards, it just matters that we went 8 meters. So it's 8 meters plus from here, we traveled again from negative 5 meters back up to 3 meters. So here's another 8 meters of travel. Again, it doesn't matter that it's forward. So that's our total distance over this motion is 16 meters. Something else that we can calculate displacement and distance, and we can also calculate the velocity. So there are two types of velocity that we're interested in, right? We're interested in average velocity and instantaneous velocity, and also average speed. So let's start with average velocity. The average velocity is the total displacement over time. So change in d over change in t. We said that our displacement was 0. 0 meters over the total time is 10 seconds. So our average velocity turns out to be 0 meters per second. Our average speed, on the other hand, has to do with the total distance. So we have total distance over time. And we said the total distance was 16 meters, and our time is 10 seconds. So the average speed is 1.6 meters per second. Write that better down here. 1.6 meters per second. That's our average speed. And the other thing that we're interested in is instantaneous velocity. So instantaneous velocity is the slope of the line at the point that you're interested in. So instantaneous velocity is the velocity at one instant in time. And that's equal to the slope on this position time graph. So if you're interested in the instantaneous velocity at 3 seconds, let's say. So we're looking at our graph. Here's 3 seconds. We want to look at, we want to know what the instantaneous velocity is at that point on the graph. So what we're really interested in is the slope of this line. Since it's a straight line, we're interested in the slope of that line. So we just find slope, which is the change in y, rise, over the run, the change in x. We pick 2 points. So here let's pick some easy points. So this is, the point here is 2, 3. And we'll pick this point down here. And this is 4 seconds and -5 meters. And then we plug these points into our slope equation. So the change in y is -5 minus 3 over the change in x, 4 minus 2. And we get -8 over 2, which is equal to -4 meters per second. Okay, and remember that's the instantaneous velocity. So the instantaneous velocity at 3 seconds is 4 meters per second, or -4 meters per second. Negative means backward, right? So we're going backward at 4 meters per second at 3 seconds. The other thing that you can calculate from this graph is instantaneous speed. Let's get a new graph here. So instantaneous speed is really the absolute value of the instantaneous velocity. Turns out I don't need a graph. The instantaneous speed, let's see, I'll do it in green. Instantaneous speed is the absolute value of the instantaneous velocity, because it's always positive, right? So since our instantaneous velocity is 4 meters per second the instantaneous speed, so the velocity is negative 4 meters per second, the instantaneous speed is positive, or just 4 meters per second. It's the magnitude of the entire motion. So instantaneous speed, doesn't matter if you're going forward or backward, it's the entire motion. Okay, so that is what we can tell from a position time graph like this. We can sort of look at it all at once and see what the object is doing. We can calculate displacement, we can calculate distance, we can also calculate average velocity, average speed, instantaneous velocity, and instantaneous speed.